Okay, so yesterday I was telling you, okay, here's the plan for the next few days. And I totally forgot that I won't be here on Monday, so that plan is out the window, okay? And we have to revise the plan. So today, we are going to spend the bulk of the day working on acceleration stuff, just making sure we get all the algebra and we're good at it, okay? And we might, near the end of the day, start looking at vector addition. Friday, vector addition, okay? Monday, vector addition. And then Tuesday, we'll do the acceleration line. Okay, so Monday, Mr. Van Erf will be here for me, okay, because I won't be here, and he will be playing a recording of me going through how to do vector addition. Okay, and so just pay attention to that. It's the next best thing to me being here. He's also, pretty good. He was a biology guy, but he can generally figure the physics stuff out. So if you have questions, you can ask him, and he'll be able to help you out. Okay, and then like I say, Tuesday we'll do the lab on acceleration. And then we'll continue on with vectors, because vectors is something we spend like 7 or 8 classes on. Okay? It's kind of a big deal, kind of governs everything we do for like 2 months after that. So it's kind of an important thing, a lot of trig, okay? That kind of stuff. So that is what we'll be getting into possibly even today as we go along. But what I want to start off with is a few more acceleration examples. Okay, mostly to get you familiar with some of the word tricks that can happen in an acceleration problem. Okay, this one here would be a prime example of a question that has word tricks in it. All right, so I would say copy this one down and see if you can solve it. Because it doesn't seem like it gives you very much information, and that's part of the word trick. Okay, so I'll give you a few minutes on that one. Okay, what are the tricks in this one?
For acceleration, you use gravity.
Yep, for acceleration I use gravity because I have to assume that bolts only exist here on Earth. Okay, we don't know that they exist anywhere else for sure, so we have to kind of go with that. Okay, that here the acceleration due to gravity is 9.81 meters per second squared down. Okay, what's the other trick?
The initial velocity is 0.
Yep. Yeah, the initial velocity is 0. If something falls off, that's the equivalent of being dropped. Okay, it wasn't thrown downwards or upwards. It simply fell off or rolled off. In either case, it's not moving vertically at time 0. Okay, so its initial velocity has to be 0. So that's the 2 word tricks that can happen, especially in a question about falling objects. Anytime you see something that's falling, you automatically know gravity is the acceleration, unless you're told otherwise. Okay, like it's falling on the moon or on Mars, where g would be different. Okay. All right, so the other thing we know is the distance it falls, 6.0 meters. Okay, down. How long will it fall for? All right, so we're looking for time. Okay, what formula am I going to use? Miles, what formula am I going to use?
I didn't really use a formula.
Oh, okay. How'd you do it then?
I did distance divided by acceleration.
Distance divided by acceleration. Okay. If I go distance divided by acceleration, is that going to give me the right units though? Right? If I divide meters by meters per second squared, I'm not going to get seconds for my units, right? I mean, it's a good try for sure. It's something to, okay? Well, we should have, what we want to do is we want to look for a formula that has these 4 things in it. Okay? And we have one, okay? It's this one here. And I only bring this up, guys, because this is always a good way to check if what you're doing is going to work. Do what we call a unit analysis. Okay, because if you're unsure of a formula, that happens. Okay, it happens all the time. Put your units in it and see if you get the units of the thing you're looking for. If you don't, then it's probably not going to work. Okay. All right, so D equals VI times T plus 1/2 AT squared. You know that formula I told you never have to use to calculate time unless VI equals 0, which it does in this question, which means I can get rid of that right now. And now I can manipulate for time. So to get time by itself, I'm going to divide both sides by 1/2 of A. Okay, and then That gets me t squared. What do I want? I want t. Okay? All right, so now I've got the right formula. Now I just need to plug in my numbers. So we'll have our 6 divided by 1/2 times 9.81. And I can make both of those negative if I want to, but do I have to? Since they're both down, down can be positive. There's no upward movement here. I don't have to make them negative. But if I do, as long as I make them both negative, I'm good. All right, so square root of 6 divided by 4.905. That's half of 9.81. Okay. All right, it's going to fall for 1.1 seconds. Okay, 2 significant digits.
I did it differently, about the same answer.
Okay, did you do it in 2 steps?
Yeah.
Yep, that's okay. There's usually more than one way to do a question. Okay, you did it in 2 steps and got the right answer, you're good. Sometimes this comes up when I do a question like this. Mr. Coderre, 0 has 1 significant digit. Does it? Yeah, you can't measure 0. Therefore, 0 has an infinite number of significant digits because it is impossible to measure and thus cannot be a measured quantity, which is what significant digits are all about. Okay? Since it's not something I can measure, it's not measured and thus does not affect my significant digits. Okay? All right, questions on that one? Okay, so a couple of little word tricks in that one. Okay, final velocity. Ooh, I missed something in this one. What is the final velocity of a rock that is propelled over a 0.30 meter? This shouldn't be velocity. That. Based on the rest of the question, guys, why should that not be velocity?
No direction.
There's no directions in anything in this question. I can't possibly calculate a velocity with everything else being a scalar quantity. So we're going to substitute in what should be there. What is the final speed of a rock that is propelled over a 0.30 meter distance by an acceleration of 22 meters per second squared for a 0.72 second interval? All right, give that one a try. Okay, let's have a look at this one. So we're looking for VF because they ask us for the final speed. Okay? And they tell us that it's propelled over a 0.30 meter distance. So they give us D, which is in lots of our acceleration formulas, okay, by an acceleration of 22 meters per second squared. And it's for a 0.72 second interval. Okay, so I'm looking for VF. I've got D, A, and T. What formula should I use? Yep. Exactly. Okay, this is the only formula that I can use in one step. Thank you, Mr. Dickey, to solve that problem. Okay, it's got all the things that I was given and the thing I'm looking for. All right, so I need to manipulate for VF. So, what do I move first?
1/2 AT.
Right, and how do I move it?
Put a plus and you cancel it. Plus.
Exactly, I'm going to add it to both sides. So plus 1/2 AT squared D plus 1/2 AT squared equals VF times T. How do I get VF by itself? Divide by T. All right, so now I'm solving for VF. I just have to plug in my numbers. Okay, so that's going to be 0.3, not times, plus, okay, 1/2 times 22 times 0.72 divided by 0.72, and this 72 has to be squared. I forgot to put that on there. Okay, and when we plug all of that in, okay, so 0.3 plus 0.5 times 22 times 0.72 squared divided by 0.72. Okay, so we're looking at 8.3. We only have two significant digits, so 8.3 meters per second. All right, we can't put a vector on that because we don't know what it is, and they ask for speed anyway. Everybody all right with that? Now, at this point, sometimes there's kind of, people are starting to get a little bit frustrated because they're doing all of this right, but they're punching it into their calculator and not getting what I'm getting, okay? And so if that's happening to you, make sure you have a look at how I punch it into my calculator. There's a lot of times where I'll do part of it and then I'll hit enter, right? Because I'm wanting to make sure I've done that part first and then do the next part. For a lot of our formulas, especially if they involve addition and subtraction, okay, or exponents, if we don't separate the parts, your calculator will do order of operations. So if you enter it all in one long string, your calculator will automatically perform order of operations and you will get a different answer and it won't be right, okay? Because you sometimes need to do the top before the bottom, okay? Everyone follow me there? So if that's been happening to you, that's kind of why, and just kind of watch as I'm doing the calculation part where I'm separating things. Usually it's top from bottom. Okay. This 62 meters per second is forward. Okay, actually we'll just say positive. Put a vector on that. Okay, there you go. Give that one a try. Okay, so yesterday we had this trick like a number of times, right? And the trick is, it tells us that the bullet slows down. So what does that tell us about the acceleration? That it's negative. Yeah, that's just the thing we have to watch out for. Okay, they're not always going to say the acceleration is negative this, but they might say it slows down. Right, so negative 150 meters per second squared. Okay, the time is 0.252 seconds. The final velocity is positive 65.2 meters per second. Okay, so we're looking for the initial velocity. What formula should I use?
Vf squared equals Vi squared plus 2AB.
Do I have D?
Oh, no,
I don't think I can use that one.
Vf minus Vi divided by T.
Yep, use our good old science 10 formula. Okay, we got change in velocity, okay, over time equals acceleration. We know the acceleration, the time, and the final, so we can solve for initial. So what I'm going to do is multiply both sides by t, add vi to both sides, and then subtract t times a. So what I'll be left with is vi equals vf minus t times a. So that'll be positive 65.2 minus 0.252 times negative 150. Not plus, minus 0.252 times negative 150. Okay, is that a very fast bullet? You could go full matrix on that bullet. You could dodge it. At 100 meters per second, that's a slow bullet, really slow for a bullet. I mean, we talked about one yesterday that was almost 900 meters per second, okay? This is a pretty, like this is a pellet gun, okay, is really what we're looking at here. It's not a fast moving, I mean, it's fast enough, you're not gonna outrun it, but, okay, it's certainly not, you know, super dangerous at 100 meters per second, okay? Questions on that one? So, here's something that is bad about this question that I won't do on an exam but can be helpful to you. The answer to that question doesn't make sense. Like I said, I'm coming up with excuses for why that bullet is so slow. Okay? On an exam, if your answer doesn't make sense within the context of the question, you probably did something wrong. Okay? So if we're talking about, you know, a turtle, that's, crawling along the beach, and it's an acceleration question, and you get the final velocity to be 150 meters per second within the context of that question, that doesn't make any sense. We were talking about a turtle, okay? There's no way a turtle goes that fast. Okay, maybe you forgot to square root it. Maybe you're using that formula, okay, where you were, using VF squared and VI squared and you forgot to square root, okay? But your answer should make sense within the context of the question when you're doing questions, especially on an exam. Okay, so if you look at that and go, there's something wrong, okay? Because I would not make a question on an exam, especially where the answer wasn't logical. Because a lot of people will look at that and do exactly that. That doesn't make any sense. I must have done something wrong. Yeah, if it doesn't make sense, you did something wrong. Okay, so it's always a good way to kind of check it. Okay. I think we've done one with that one already. Yeah, let's do that one. No, sorry, we've already done that. We've already done one like that. Okay, in your digital workbook are these questions here, okay? And it is on page... So it starts on page 6. So actually, let's just skip number 1 because I don't like how that one's worded and I keep meaning to change it. Okay, so on page 6, okay, starting with question number 2, there's a bunch of acceleration problems there. Okay, big thing is figure out which formula you got to use. Okay, that's usually the most challenging part of the question because the rest of it's just algebra. All right, and then if there are any that give us trouble, we can go through them together. Okay.